Hey guys, I'm just going to do a short video over the review for our test tomorrow. It's going to be pretty fast, so make sure you pay close attention, pause the video when you need to, send me a reminder, an email, or a Canvas message with any questions. Number 1, given a parabola that has a vertex at the origin and a directrix at y equals 3, find the equation of the parabola in vertex form. Key things, the vertex is at the origin. This means it's at 0, 0. That means that my h is 0, my k is 0. Directrix, y equals 3. That means I have a directrix at y is equal to k minus c. So then I can say 3, because it says y equals 3, so I can replace y with 3, is equal to 0 minus c, because I know the vertex, hk, so I know k must be 0. So I know 3 is equal to a negative c. Divide both sides by a negative 1. And so then I know that negative 3 is equal to c. So then something else to remember is that we learned earlier on that a is equal to 1 over 4c. And if a is equal to 1 over 4c, and c is equal to negative 3, then I can say 1 over 4 times negative 3. Well, 4 times negative 3 is negative 12, so this becomes a is equal to negative 1/12. I am now ready to write my answer in vertex form. Y is equal to negative 1/12 x squared. Now you might ask, why didn't I write x minus 0? Well, I know that h is 0, so what is x minus 0? It's just x. So writing minus 0 plus 0 wouldn't have meant anything. So that would be my answer. Now, I would not mark you wrong if you wrote this. I would not mark you wrong if you had written x minus 0 squared plus 0. That would be acceptable. Okay, it's just h is 0 and k is 0, so they don't really add overall to the problem, so I don't ever write them. All right, number 2. Given a parabola that has this vertex, so h is negative 5 and k is 4, and a focus at this, find the equation of the parabola in vertex form. The fact that we know the focus means we know, you should remember that a focus is the point h comma k plus c. Well, we already knew h, we knew that from the vertex, but it's always good to double check. We got negative 5, so that's good. We know our h is correct. Then we know k plus c is equal to the y value of the focus, and in this case we know the y value of the focus is 0. Then we already know that k is 4, so I can say 4 plus c is equal to 0. Subtract 4, so we know c is equal to negative 4. Well, once again, we're going to use the same information we did in the prior problem. We're going to use the idea that a is equal to 1 over 4c, and this time c is negative 4, so we know that that is equal to negative 1 over 16. That's a 16. So then we know that y is equal to negative 1 over 16 times x plus 5, since h is a negative 5, and the formula is x minus h, the double negatives turn it positive, plus k, so plus 4. And there we go. All right, and number 3, state the transformations. All right, well, I'm going to type these out because that's just going to be a little bit easier for me. The negative sign right here means it reflects the x-axis. The 3 right here means that it is a, where am I typing? Let's see if I can't get it typed. A vertical stretch by 3. All right. The minus 5 right here means, I messed with something. Somehow I have this little weird thing right here. Means right 5. And the minus 11 means down 11. All right. I want this to go away now. Why is it not doing that? Let's see here. Okay, let's just get rid of it. Okay. Oh, somehow I typed this in the actual Word document. Okay, I guess that would have made more sense. All right, state the transformations. Okay, this 3/4 right here, guys, that means a vertical compression by 3/4. The plus 7 means left 7, and the plus 8 means up 8. And there you go. All right, number 5, it gives me a graph and wants me to state the zeros. Remember, zeros are where I cross the x-axis. I'm only touching the x-axis one place at negative 2. So I only have 1 0 at negative 2. Axis symmetry, remember, axis symmetry is always x equals the x value of the vertex. So x equals, here's your vertex, what's the x value right there? Negative 2, so x equals negative 2. Is it a max or min? It's a minimum. And what is the y value of the vertex? That's what it's asking. So 0. So there I go. And then what actually is the vertex? Well, don't forget your parentheses to indicate it's a point, but it's negative 2, 0. All right, moving on. Let's see. Somehow I have adjusted number 6 in a way I did not mean to. Okay, there we go. Let's hope that kind of cleared up my formatting. All right. Once again, it asked me for me to find the zeros. Well, it doesn't ever cross the x-axis, so there are none. The axis symmetry is x equals 2. Is a minimum at 5. And my vertex is the point 2, 5. Okay, number 7, it says find the vertex, and it gives me a standard form equation. The trick to doing this problem is to remember that the vertex is the point hk, where h is equal to negative b over 2a. And standard form is ax squared plus bx plus c, so a, b, c. So then this is equal to a negative b, so a negative 4, divided by 2 times a, so 2 times 2. So that's just going to be negative 4 over 4, which is negative 1. That's the h value. To get the k value, I just plug it back in. So 2 times negative 1 squared plus 4 times negative 1 plus 1. You type that in a calculator, and you're going to get negative 1. So the vertex is the point negative 1, negative 1. Easy breezy. All right, number 8. Find the vertex of y is equal to 3x squared minus 18x plus 1. Same idea. Remember that h is equal to negative b over 2a, so negative of negative 18 over 2 times a, which is 3, so 2 times 3. Well, double negatives turn positive. 18 divided by 6 is just 3. So we take the 3, we plug it in, we get 3 times 3 squared minus 18 times 3 plus 1. Let's see here. Let's use our calculator. This is always the weirdest part of my videos. 3 times 3 squared minus what I believe is 54, but we don't actually get to check that for sure. I mean, I could, but it's not that big of a deal. Plus 1, I get negative 26. All right. So 3 comma negative 26. All right, moving on. Make sure I can move on here. All right, number 7, a man throws a ball at the top of the building. Of course, I have the ball at different times, shown on the table. Find the quadratic model of the table. Okay, all I want you to do is go to Stat, go to Edit, type your X's in L1, type your Y's in L2, second mode, hit Stat again, go over to Phi, press Enter, boom, A, B, C, plug it in, you got your answer. Use the model to estimate the height of the ball, 2.5 seconds. You literally are just going to plug in 2.5 for everywhere you see an X. Plus 3 plus 46. Press enter. Bam, 28.5 feet. That's the answer to B. What is ball's maximum height? Remember, we got to find the vertex. So we got to do negative B divided by 2 times A. Whoops, I'm going to mess up. I just got on to one of my 8th period students by doing it that way. And I am not typing this in right. Negative 33 divided by 2 times A, which is a negative 16. And that gives me that number. Plug that number back in to get your 1 point. To get the height. Okay? Because remember, if you're plugging in an X, you should get a Y. So if you're plugging in a time, that was the X value of the vertex, then that should give you the Y value of the vertex. So since we're plugging in X, we're plugging in the X value, the time of the vertex, which is the maximum height. And so therefore, the outcome should be the actual maximum height. That's 46. And so the maximum height is just 63.0 or just 63. All right, guys, I tried to fly through that video. If you have any questions, please let me know. Thanks. Have a great day.